Hello everyone, this is Giorgio Bada, and today I'm gonna take you through our Mechatronics project, which consists of making an air dehumidifier. Together with my team, I'd like to present in a short video how our system works. First things first, I'd like to introduce the basic idea behind our mechanism. Just to note off that our mechanism relies on the principle of function of a Peltier, which basically takes in DC current on two ends and produces a hot surface and a cold surface. Therefore, we need to attach heat sinks onto it, one on the cold part, one on the hot part. After that, we must realize that water condensation phenomena is happening. After that, we are able to read the temperature and humidity in a room using the Arduino DHT11 sensor. Again, we need to point out that there should be a human in the middle, which basically sets the threshold at which the desired humidity must stay constant at. And then we are able to dehumidify the air in the room by using the water condensation phenomena, which takes place on the cold part of the Peltier. You can see that actually the real graph that we obtain during the logging data process, and you can see that the humidity gets down and down until we increase it artificially, then it goes down again and stays constant at the desired threshold. In case that you guys are asking how cold the heatsink gets, you can see I decided not to crop this image specifically to show that it's our real working. And by measuring the temperatures, you can see it's only ice here. It's about minus 30 degrees Celsius, and on the hot side, it's about 100 plus degrees Celsius. Now it's time for a demo, but before that, I'd like to introduce you to some specific points that I consider being important for our entire mechanism as a whole. Firstly, it is reliable and robust. Secondly, it has a wide usage capability. It can be used in both large or narrow spaces. It is fully functional, and as an example, in 1 hour of working, it decreases the humidity from 47% to 35% in a big room. It is powered via mains. After the first input, it works independently, no human action required afterwards. And we are proud about the thing that it is not only a proof of concept, but it's a working and functional mechanism too. Now let's see the demo. Okay guys, now I'm gonna make a little demo of how our system works. Firstly, we have to plug into the mains. Just know that there is only one cord which goes to the mains and in the back to a power supply. We plug it in, we can see after some seconds the DHT sensor will read the humidity and the temperature in the room. Currently it is 35% humidity and the temperature is 24 degrees Celsius. Let's say I want to threshold the humidity so that my system works until it reaches that humidity. I press on D, it asks me about the maximum humidity, let's put it 20. Then we press D again to set the threshold. And you can hear the relay started and the fan started as well. Basically, we have two fans, one in the front, one in the back. I'll show you in a bit. The purpose for the fan in the front is to suck in the air from the room, and one on the back has basically two purposes. The first one is to get rid of the air which is already dehumidified, but in the same time cooling the hot part of the Peltier. One additional feature, we have a tray which you can open and close, as you can see. Maybe I can put it. Okay, we can get it off and on, and basically here is where the water from condensation accumulates. I'll just make another demo of that, of how we expect the system perform when the tray is full. I don't want to waste your whole day on that, so that I have to do it artificially using a glass of water. Now, when I'll put the water sensor in it, you'll see this red light which should go on, but also the entire mechanism must shut down. Let's see. Okay, you can see that now the system stopped completely. It is the red LED is activated, and now if I take it off, I must expect in some seconds. Okay, it's on again. It's producing water again. One more thing to note here, we have the DHT11 sensor, which obviously has to be on the outside of the case, which reads basically the temperature and humidity. On this side, there are just a bunch of cables. In the back, I told you there is a fan here, which gets rid of the air already dehumidified,
and it's cooling the hot part of the heatsink. And in the same time, we have a power supply, which is the only one we have in this system, and it's connected to mains, and it provides 12 volts for our entire mechanism. I can tell you that the system works flawlessly after 2 to 3 hours for a big room. It is able to reach the thresholded humidity, but more than that, it stays constant there, as you already have probably seen in our graphs. Thank you for listening, and I hope you enjoyed it.
Lastly, I just want to give you guys a sneak peek in our past work and also some insights about what future work can be done here. That's the building process that we got through. And you can see here on the left, there's the Arduino board connected with all the wires, and basically there's the Arduino mechanism that our project relies on. And here on the right, you can see how we managed to fit them all inside the case. Believe me, that was a quite painful process, but hopefully it went out well. About future work, I can say that our system might perform even better if we had more peltiers, therefore increasing the functional capability. If we had some resistors or some sort of heaters that regulate the temperature as well, and in the end, it's probably gonna be better if we had an IR sensor so that we are able to operate the system remotely. Thank you for your attention.